Hi, in this video, we're going to talk about co-function identities. And I really want to emphasize on those two letters, C-O, because that refers to complementary. So in all those identities, we're going to be talking about complementary angles. So I'll come back to those notations, sine of pi over 2 minus theta equals cosine of theta and all the other identities. But before I do that, I would like us to recall one of the SAT Bellware questions we did together. The question was, in a right triangle, and they did not give you the triangle, we built it together. One angle measures x degree, where sine x equals 5 over 13. What is the cosine of 90 minus x? So let me remind you what we did in this case. We drew a right triangle. So we highlighted keywords. Right triangle, it means it has a 90-degree angle. We placed angle x anywhere where we would like other than the right angle. So we placed the x right here. And we applied sine equal opposite over hypotenuse. So we looked at the opposite side, which is across from, it was 5. The hypotenuse is 13, so we placed that on there. Now, to understand the question, it says, what is the cosine of 90 minus x? And that was the key. If you understand what does 90 minus x, it will be very easy to solve the question. And actually, 90 minus x would be the third angle in the triangle. This is a 90-degree angle. The sum of angles in a triangle is 180. But when we have a right triangle, there is a 90-degree that goes to the right angle. And the other 90 will go to the other two angles. So if one of them is x, the other one, we can find it by doing 90 minus x. An easy example would be like if we had a 10-degree, how would I know the third angle? I'll do 90 minus 10 and I'll get 80. And that way I'll have 80 and 10, that's a 90, and the right angle, another 90, that will add up to the 180 degrees. So the key to solving this question is understanding that the third angle right here would be 90 minus x. The question is not what's the angle, but the question is what's the cosine, which is adjacent. And if we look at the side next to it, it will turn out to be that 5 over hypotenuse, because adjacent over hypotenuse is the cosine. So we will get 5 over 13, which was the same as the sine of angle x. Angle x and angle 90 minus x, we call them complementary angles because they add up to 90 degree. So in general, 90 minus x and angle x, if we add them up, the x and negative x cancel out, they add up to 90 degree. If you had numerical example, like let's say x was 20, the other one would be 90 minus 20, which is 70. They add up to 90 degrees. So we concluded and said the sine of an angle theta or x is equal to the cosine of its complementary angle, which should be 90 minus x or 90 minus theta. Going back to our co-function identities, instead of using 90, we used pi over 2. And instead of using x, we used theta. So 90 minus x and x are complementary, or pi over 2 minus theta and theta are complementary angles. Why? Because if we add them up, theta cancel out, they add up to pi over 2 or 90 degree. And we can see how the sine of one will switch to the cosine of the other one, and cosine will switch to sine, tan switch to cotan, cotan to tan, cosecant will switch to secant, and secant to cosecant. That's in complementary angles. A famous example on the unit circle of complementary angles would be, take a quick 10 seconds to think about it, two angles on the unit circle that could be complementary are pi over 6 and pi over 3. So the 30 and the 60, yes, they do add up to 90 degrees. Let's look at the pattern of their sine and cosine. So let's look at cosine of 60 degrees. What do you notice? The cosine of 60 equal the sine of 30 degrees. And the sine of 60 equal the cosine of 30 degrees, which is a good example or a good proof of how we can apply those cofunction identities. So the cosine of 60 degree equal the sine of 30 degree, and the sine of 60 degree equal the cosine of 30 degrees. Now, it's not going to be as simple as cosine and sine of 30 degrees and 60 degrees. It's going to be a little bit more complicated when we work on our objective, which is simplifying trig expressions, but we will definitely see together how we can use those cofunction identities in simplifying trig expressions. I fixed this to the color code we have used. The blue refers to the cosine of 60 and sine of 30 degrees, which are equal. The pink will refer to the sine of 60 degree, which is equal to the cosine of 30 degrees. And to match how the identity is written, 60 degree is nothing but 90 minus 30. So that would show us how we can write this as a general statement. Instead of 90, it's pi over 2. Instead of 30, x or theta equal cosine of theta.